Good morning, afternoon, or evening, wherever and whenever you are. My name is Benjamin, and welcome to part 2 to this Godot 4 Action RPG YouTube series. In this video, we're going to start animating our character using two nodes, the AnimationPlayer and the AnimationTree. We'll start by coming over to our player scene, clicking on Player and clicking the plus button. Here we can type in Animation, and we'll get an AnimationPlayer and an AnimationTree. Let's add the AnimationPlayer node first. An AnimationPlayer node allows us to create animations down here in this panel right here, and we can create keyframes for any of the properties over here on the right. How we position those keyframes on the timeline down here will create an animation, and there are basically unlimited ways in which we can use this AnimationPlayer. We can animate pretty much anything in our game that we'd like to, so they're very powerful. We're going to start by creating a new animation. We'll just click Animation New, and we can call this one Stand Right. Now if we click on our sprite and come over to our frames in the animation, we can key frame 0, just like this, and it's going to want to create a reset track for us. That is just the track that Godot uses whenever it needs to reset the scene over here, the properties in the scene, to their default values. So we do want it to create this reset track. We'll just let it do that automatically for us. And now we have this single frame down here in our stand animation. By default, Godot currently sets the nearest FPS or the snap time here in our timeline to 0.033. We're going to set this to 0.1. I find this to be a lot more useful for 2D pixel art animations like this. And then the animation length right here is set to 1 second by default, but for this stand, we only need 0.1, a tenth of a second. And we can use this right here to zoom in on our timeline. And then we can click this right here to turn on snap. Now, Godot also allows us to loop this animation right here with animation looping. We don't actually need that for this because it's only a single frame, but you might have an idle animation that has multiple frames, in which case you would need to use looping. This animation is done. Now we're going to create a new animation, and we'll call this one Run Right. And if we come over to our frames, we'll select frame 1. This is the first frame in Run Right, so we'll key that, press OK. And then Godot is automatically going to, now that we've set this to 0.1 and set up some properties, it's automatically going to advance to the next tick in our timeline and to the next frame over here. It's trying to help us do this animation more quickly. So we should be able to just press key, 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 key. And then our last frame is actually going to be the first frame. So it's going to loop all the way back around to frame 0 right here. Now, why did I start on this frame instead of on this frame? That's because I want our animation to start, the run animation to start on an action frame. That just makes it so that if the player is tapping the arrow keys, for example, it will show this action frame as the very first frame, rather than the standing frame, which would just allow the player to kind of like slide along the ground while standing. Once we've set this up, we can switch back to, we can set the length for this animation to 0.06, which is going to work great for this. And then we'll set looping to true on our run, and we can run this animation in the editor and watch it play out. You can select these frames down here in the timeline. You can even move them around or manipulate properties of them. We're going to leave them just like they are. I just wanted to mention that so that you know that is something you can do. Let's click back on our sprite, and you can see that the next frame we want to get to is actually this right here, frame 6. This would be stand up. Now I'm going to pause recording here, and I'm going to do stand up, stand left, run left, stand down, and run down. And I'm going to challenge you to create all those animations as well. So I'd like you to pause the video and then create those animations. And when I get back, I'll have them finished. I'll show you how I set them up, and you should be able to get them finished as well. And you can kind of compare notes with me once you're done to make sure that you've got it done correctly. So here we go. Pause the video now and set up those different animations. Okay, so I've set up those other animations. I have stand down. You can see the animation length, stand left, stand right, and stand up. And then I also have run down, run left, run right, and run up. Now you want to make sure that you've set the animation lengths, and for the running animations, double check on each of them to make sure you set animation looping to true. Really easy to go set up those animations and then just forget to turn on looping. And if you do forget to do that, then your animation wouldn't loop when your character was running around in the game. It would go through one cycle and then stop, which would look pretty funny. Now that we've set up our character's animations in the animation player, we're going to add an animation tree. So click on player, the player node, click plus, and add an animation tree. Now the animation tree has to have an animation player that it modifies or kind of controls. So if we come over here, we can see there's an animation player property. We can click assign and select the animation player that we just set up. Now animation trees are a little bit more of a tricky topic, but they're important to cover because they're so powerful. And so don't feel bad if you don't understand everything right away. As you continue to learn about them and use animation trees, you'll be able to understand them better and better. But for now, I'm going to try and keep it as simple as possible because I do think they're really important to learn early on because of how powerful they are. In the same way that we have our scene over here, and this scene has different nodes, and there's parent nodes and child nodes, almost if you imagine a folder structure in a computer where you have folders higher up, and then you can have folders within folders and stuff like that. We can have a node within a node, essentially, when it's a child of a node. The animation tree also has this tree-like structure to it. And that's why it's called an animation tree. And it has to have a root node. Just like our scene has this root player node, our animation tree has a root node. And we can add one by coming over here to this, and we can select a root node. Now, there are a lot of different types of nodes here, just like there are a lot of different types of nodes that we can do in our scene. But the most common root node for an animation tree is actually an animation node blend tree. So this one right here. We're just going to select that. And then if we click on it, or actually we have to come down here and click on the animation tree tab, it will show us our root node right here. And you can see this path, just like in a folder path on a computer, as we add new nodes and go down deeper, or if you imagine the folder analogy, we will see this path go down deeper as well. Godot is mad at us because we haven't attached a node to this root node yet, and it wants us to attach one. So we're going to add a new node, and the node we're going to do is going to be a state machine. We can just drag this over. See, we've got this visual editor here, and we can connect our state machine to our output. So just connect state machine down to output like that. Now Godot is not mad at us anymore. And this state machine is also a node. It's an animation node state machine playback. You can see that right there. It's also a node. And if we open in the editor, now we've come inside of our state machine, and there's this whole visual space here where we can create a state machine. And you can see in our path we have root, and now we have state machine as we're getting deeper down this tree hierarchy. Now inside of our state machine we can also add nodes, and we do that with this little create new nodes plus right here. So we're going to press this, we're going to click in here, and we're going to do another state machine. Now that might be a little confusing, but once you've done that, click back on the arrow key, because this can get a little finicky if you don't have this cursor selected. So we'll click back on that, we'll move this over here. Now this state machine, I accidentally went inside of it, so now we're root state machine, so I went too deep. It's possible you might have done that too, so it's actually good that I accidentally did it. We want to come back out of this state machine. So we're going to click on this right here. Okay, so now we're back one level higher, and we can select this, and we're going to call this move state. Now the reason I made a state machine within a state machine is because our move state is actually going to have two of its own states. So we need to connect our start to our move state. That way the move state will automatically play by default. And to create a connection, we can click this, and we'll just have the transition be immediate and automatic. That's what those things mean. We can click here and drag over here. And now we have an immediate and automatic transition from start state to the move state. Select our cursor again. Now we want to come into the move state. We want to edit inside of here. And we're going to create two new nodes inside of here. The first node we're going to create is going to be a blend space 2D node. So what is a blend space 2D node? A blend space 2D allows us to create, it allows us to connect multiple different animations. So our character has multiple different stand and multiple different run animations, right? Run up, run left, run right, run down. It allows us to connect those together into a single stand state or a single run state. And then have this blend space pick which animation to play based on which direction the character is moving in. So if they're moving up, it will play run up. If they're moving right, it will play run right. And it automatically does this for us in a way that's useful, and I highly recommend blend space 2Ds. They're more commonly used in 3D, but they're very useful in action RPG games like this, where you might have an animation that needs to animate in multiple directions. This game only has 4 directions, but you could easily do this with 8 directions as well. So let's actually create 2 of these. We'll just, while we're at it. And then I'm going to select our cursor, and I'm going to name this one stand state. And I'm going to name this one run state. And then I'm going to move this down here. And this, well, let's connect stand here and run right here. And we can middle click to pan here, and I'm going to automatically and immediately transition into the stand state, just like that. Okay. Now we're going to come in and edit this node. And you can see we get this fancy, really fancy animation space right here. And this is our blend space. So we've got this grid, and we can place animations on this grid. We can click over here to create a point. We'll click here. We'll add an animation, and we'll do, this is stand. We've got stand state. So we'll do stand left. And then we'll click up here, add an animation, stand right. No. That should be stand up. Well, we'll fix it in a second. Over here, stand right. And then down here, add an animation, stand down. I'm going to select the cursor and click on this one. It's stand right. We want this animation to be stand up. So left, up, right, and down. And you can move these around as needed. You need to move them at all. But the positions that I'm putting them in just allows us to set this little cursor, and as this cursor moves around in this space, it will automatically choose the animation that it is nearest to. So if we come back into our state machine and we press play on the move state, and then we come into the move state and we press play on the stand right here, and we come into here, as we if we select the set blend position, should be able to move our character around in these animations. Now, I swear I selected stand and not run. Stand, 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 and stand. Those are all correct. So, but what is happening, I did select stand and not run. what is happening is that it's trying to interpolate between these images. Okay? And that's because it's set to continuous right here. So continuous will try to interpolate between these frames, each of the frames in these animations. And we don't want that because we're not doing a 3D model that can smoothly interpolate between different key frames. We're doing an animated sprite that can't do that. So we're going to switch to discrete. And now as we move this around in this space, you can see that our character updates accordingly based on which direction that it should be facing. Okay, let's by default have it start with down. Now let's come back into our move state and we'll select our run here. We'll switch to discrete. And I'm going to pause the video and have you pause the video so you can try and set up the run animations inside of this blend space 2D. So I'm going to do that off screen and have you do it off screen as well. So pause your video now and try it yourself. Okay, I've set mine up. I've got run up, run left, run right, and run down, and I've switched it to discrete. Now if I come back into move state and I press play on the run state, hopefully it will allow me to play it and come into it. It doesn't look like it's going to. So we're going to have to create a connection here in order to test this. So we'll connect down here. We can just have it be automatic and immediate. Press play. And there. Now as we move around. Oh, I accidentally did stand down. That's probably part of why I was having issues. Let's select that and do run down. Run down. There we go. Now I can move around. Maybe I didn't even need that connection. And we can see our character is now set up correctly with run. And also, let's select this transition and then delete it and then play the stand state. And we need to create transitions between our stand and run state. We can click this transition and we're going to keep immediate and automatic turned on. So if we drag down, that creates a transition down to the run state. And if we drag up, that creates a transition back up to the stand state. Now our animation player is freaking out because it's automatically and immediately transitioning between these two states. So it's switching between the stand and run state quite quickly. So what we can do is we can actually select our transition right here and come over to advance. And we're going to have an advance expression that we use to determine when it should transition from the stand state to the run state and when it should transition from the run state to the stand state. For now, we can just do enabled for the advance instead of auto. So we'll just turn them both to enable. That will save it from switching immediately. The advance expression is going to be like writing a teeny bit of code here in the editor. But we have to give it context for which that code is going to be run, because this is just the editor. It doesn't know where this code is coming from. If we click on our animation tree, we can see there's this advance expression base node property. And by default, it's just set to itself. We actually want to change that by selecting it and choosing the player. Now, anytime we put code in the advance expression box there, it's going to run that code as if it were in the player script. And this would give us access to certain variables like input vector, for example. However, input vector is not available inside of this entire script. It's a local variable right here just inside of physics process. So what we want to do is we want to make it a variable that is a property of this object and available anywhere in this script. So we'll say var input vector is equal to vector2.0. And then we can just remove the var right here And now we've moved the scope of this variable from this local function to this object. So now it's in the scope of this whole object rather than just in this function. So now we actually have access to input vector. If we come back into our animation tree and we go back into our move state and we click right here, when do we want to transition from the stand state to the run state? Well, whenever input vector dot length is greater than 0. So we can say input vector dot length is greater than 0. Okay, so if input vector dot length is greater than 0, it will automatically, we want to change it back to automatic, switch to the run state. Now if we select down here, we can do the transition from run to stand, which would be input vector dot length is equal to 0, 0.0. Then it will switch this to automatic, automatically switch to the stand state. And you can see now it's not just switching between them like it used to. We can play the stand state or we can play the run state. It's not going to infinitely switch between the two because it's using that expression to determine if it should switch between the two or not. Now if we run the game, our character stands when we're not moving and runs when we are moving. But we're not yet updating. We come into our animation tree. We're not yet updating this. What is this called? The blend position. See this blend position? We want to update that value inside of code whenever the character is moving. So how do we do that? Well, we have to get access to a few things inside of code. So let's click on our script here. And we need to get access to the AnimationTree node. So in order to get access to the node inside of our script, we can drag the node over like this, hold Control, press and hold Control, and then drop it. And that will automatically create this onReady var. OnReady just means it's going to wait until this scene is ready before trying to get access to the scene tree. And that's because if we did it right when this script was initialized, this node might not exist yet. And so that's why we want to wait. OnReady is a keyword that waits until this animation tree node is ready. Once we have access to the animation tree node, we actually need to get access to a specific property. So if you click on animation tree and then come over to parameters, you can see we have a state machine and we have a move state. And these parameters right here, they have a run state and a stand state, and we have these blend positions right here. So as we add nodes to the animation tree, our parameters over here on the animation tree will increase. We'll get additional parameters based on which nodes we've added. We want to get access to this blend position for the run state and the stand state so we can update it just like we were doing in the editor. Remember when we were updating the blend position in the editor? We want to be able to update it while the game is running inside of code. That way we can set it equal to our input vector. Okay, so in order to get access to these though, we need to get access to this playback node right here. Animation, actually for the blend position, we don't need to. I just remembered. So what we can do is we can put a if statement right here in our code that says if input vector does not equal vector2.0. If it doesn't equal 0, then we can update these blend positions. We only want to update them if we're actually moving in a direction. Otherwise, we'll just leave it what it is. And we can do that by saying AnimationTree dot set parameter. Let's see, dot set, and then we don't have to type in the parameter. If we type parameter right here, it's going to allow us to set one of those parameters. We can see we have the run state blend position. Let's set the run state blend position. And I'm going to maximize the code here. And we want to set it equal to input vector, just like that. So now we're setting the blend position to whatever our input vector is. So if we're pressing up, it will set it to up. If we're pressing down, it will set it to down. Now we can do AnimationTree.set and then start typing parameter again here. And well, let's do parameter, and then we can do the stand state. And then we can do input vector here as well. So whenever we're moving, we can update these input vectors. But if and why would we update the one on the stand state as well, even though, you know, when we're not moving? Well, it's because when we are moving, we're kind of like remembering a direction, right? Whenever we move, we're saying the character is facing in this direction. We want that direction to be updated for when they're standing as well. So even when we stop moving, they'll continue to face that direction. Now if we run, we should see moving in different directions. Now there's a problem. Up and down are swapped. Why are up and down swapped? We were doing so well, right? And we've got this bug, and we set up everything correctly, but, well, here's what it is. Inside of 2D game engines, most 2D game engines, up is actually negative y. So right is positive x, left is negative x. Up is negative y, and down is positive y. And that's exactly how it works inside of Godot. But inside of our blend space, you can see that y over here, up is actually positive 1 instead of negative 1. And down is negative 1 instead of positive 1. And that's just how it's set up by default. So the easy solution to this is just to create a new vector for direction. So we'll say var direction vector is equal to, and then we can say vector2, and then we'll do input vector.x, and then for the y, we'll do negative input vector.y, and that just flips it. That takes our input vector and it turns it into a direction vector by flipping the y. And then we can just pass that in instead of input vector. So we'll replace both of those and we can pass that in instead. And now it should work perfectly. We can move in the different directions. Now there's one last thing. When we're moving up and to the right, it uses the up animation. Whereas the other directions, it doesn't. It uses the side. Now I actually want it to use the side for all of them. The easiest solution to this problem is just to slightly adjust our points inside of this blend space. If we bring in the side points just by a little bit, oh yeah, I have to select the cursor. We bring in the side points by just a little bit. This will force it to prioritize those sides rather than up and down, I think. Sometimes I forget which one it is. I'm pretty sure this is right though. So if we bring in the side points, we'll prioritize up and down, because what happens when we're moving perfectly this way, it will end up like perfectly up and to the right. That point will end up being slightly closer to the sideways one. See how that works? Yeah, I've got it right. I've got it right. Now if we run, up and to the right is sideways, and down and to the left. Awesome, we've already got a character that can move in multiple different directions. We're only 3 videos in, and our animation tree here is just going to get better as we add new states to it. Right now we just have this move state, but we'll be able to implement an attack state, and a roll state, and other states as we add those animations. So super powerful. You can see how powerful this is. And then it's really cool that we can transition between the run state and the stand state here, just using this advance expression. Just getting the length of our input vector. Is the player pressing a direction on the keyboard? If they are, then we want to switch to our run state, which has all the different run animations. If not, switch back to the stand state, which has the stand animations. And it automatically does that. Our code is almost non-existent here. The last thing I want to do though before we finish this video is we're going to have a lot of AnimationTree set and then blend positions here. We're going to have one for all of the different animations, rolling and attacking. So I want to create a function that does this for us. So we'll make a new function and we'll call it update blend positions. And it's going to take a direction vector. Just be a vector 2. I'll return void. I'm going to maximize this, and I'm going to cut this right here, and then paste it right here. And then I'm just going to call update blend positions, and I'm going to pass in the direction vector that we set right here. That just cleans up our code a little bit here in the physics process. And as we add more blend spaces to our state machine for the different attack and roll, we can just place those in here and they'll all kind of be in one spot. So that's going to be it for this video. Thank you so much for watching. I hope you enjoyed it and learned something. Like the video, subscribe to the channel, and I will see you all in the next one.